Hello, my name is Professor Adrian, and this is episode 1 of my Quadratic Series, where we're going to talk about things like factoring and solving quadratics and graphing quadratics, all the different forms. And this video really serves as a prerequisite to all of that stuff. So specifically, we're going to be talking about classifying polynomials. One of the things that you should be able to do after watching this video is to classify a given polynomial. You should also know how to define things like term, leading coefficient, degree, monomial, binomial, trinomial, constant, linear, quadratic, and cubic. So if you already know how to classify this polynomial and you already know what these words mean, then I recommend that you jump into episode 2 of the Quadratic Series. For everybody else though, let's jump into it and let's talk about it. So what we have here is a polynomial. I know it doesn't look like anything, there's just a lot of letters and symbols, but it's a general case polynomial. What I mean by that is if I wrote something like 3x cubed minus 2x plus 1, these are the same thing, but this on top with the a's is a general case of the bottom. So we can actually match up some of these different pieces. The first piece that I want to identify is called the leading coefficient. A coefficient, recall, is a number that is in front of a variable. So this a sub n is in front of this variable x to the power of n. This a sub n minus 1 is in front of the variable x to the power of n minus 1. A sub 1 is in front of x. And a sub naught is just by itself. So all of these are coefficients. The one that is out in front is the leading coefficient. We also have exponents. Down here in this more specific example, we have a cubed, we have an x to the power of 3. In my general form, I have n to the power of 1. So the highest one, the highest power, the highest exponent is the degree of the polynomial. Now if I combine a coefficient and a variable and I look at the entire piece, we have a term. A polynomial is nothing more than a lot of terms put together. We can add them together, we can subtract them together, but they're not going to be combined because they're going to have different exponents. So this whole entire thing is a polynomial. So that's great, but how does that relate to this more specific example? I understand that this might be a little intense, but it's important to understand what all of these mean in the grand scheme of polynomials. So if I look at this more specific example down here, I have a leading coefficient. The number in front is 3. The degree is the highest exponent. So in this polynomial, the degree is 3. I have a lot of different terms. I could say that 3x cubed is one term, 2x is another term, 1 is another term. And when I put all of these terms together, it creates this polynomial. All right, now that's great, but how do we classify polynomials? What do we call them? Well, let's come up with another polynomial. Let's just make one up. We'll say negative 7x to the fourth minus 3x cubed plus 5x squared plus 3x minus 11. So given this polynomial, I have two questions for you. What is the degree? And how many terms are there? So if we look at all of my exponents, we have a 4, we have a 3, a 2, a 1 is really hiding there, and then 0 over here. So the highest exponent in this polynomial that we just made up is 4. So this polynomial has a degree of 4. How many terms are there? Remember, terms are the coefficient and the variable combined. So this negative 7x to the fourth is a term. This 3x cubed is a term. This 5x squared is a term. 3x is a term. And 11 is a term. So I have 5 terms. There are two ways to classify a polynomial. One of them is going to be based on the degree, and one of them is going to be based on the number of terms. So what I like to do is make a little chart. We can have the degree, and then the name, and then maybe we'll give an example of each. So degree, we could have 0, we could have 1, we could have 2, 3, 4, 5, 6, 7, 100, a million, doesn't matter, but we'll just go up to 4. And then we can do the same thing with number of terms. So number of terms. The name based on the number of terms, and an example. So number of terms, we can't have 0 terms, right? Then we wouldn't have anything. We need at least one term to have a polynomial. And then we could have 2 terms, 3 terms, 4 terms, etc. So if the degree of a polynomial is 0, what do we have? What could you have with a degree of 0? Well, we could have x to the 0. There could be some number in front of it, like a negative 5. But it's always going to have to be x to 0. I can't have an x squared, I can't have an x cubed, because the degree has to be 0. This, with the degree of 0, is a constant. If I go back to the previous page, there's really a x to the 0 here, and that is my constant term. What if I have a degree of 1? Well, that just means I have an x. There could be a number in front of it. It could be like 3x. And there could be something after it, plus 17. But we're worried about the degree. The degree here is 1. So what is the name if the degree is 1? What kind of function, if you were graphing this, would it look like? This would be a straight line. So we call this linear. What if we had a degree of 2? Well, we would have an x squared. My example can just be x squared. There can be a number in front of it. I can have plus, something with an x, plus a constant, but we're just going to leave it x squared. That's fine. And this is what the whole series is about: quadratics. Okay, so when you see the name quadratic, that means that there is a x squared, and that 2 exponent, that squared, is the highest exponent in the polynomial. So it is a polynomial of degree 2. But let's finish this table out. What about a degree of 3? That means that we have an x cubed. We can have a number in front of it, 4x cubed. We can have some other stuff, minus 2x plus 1. If the degree is 3, then this is a cubic. And when we get to 4, we have x to the 4th minus, 5x squared plus 3. You can probably think of an infinite number of examples for each one of these. So if you come up with a different one, that's fine. If the degree of this polynomial is 4, we can call this a quartic. Now, some textbooks, depending on what book you're using in your class, might call this like a polynomial of degree 4. If there's a 5th degree polynomial, we could call it a quintic. But now we're getting into the area where a lot of textbooks will call it polynomial of degree 5, polynomial of degree 6, polynomial of degree 7, and so on. So really, once you get to cubic, the naming scheme becomes less important. Alright, so we have names based on the degree: constant, linear, quadratic, the big one, and cubic. And then quartic and quintic and so on if you want to know those. What about based on the number of terms? If I have a polynomial with one term, it could be anything. It could be, 1,213x to the power of 500. Or it could just be 3. Or it could be, 6x cubed. As long as it's one term, we're going to call it a mono, meaning one, meal. So monomial. If I have two terms, and again, this could be anything. Let's say x to the 5th minus 2x. I have two terms. We're going to call this a binomial. Can you guess what 3 terms is going to be? Let's say x to the 5th again minus 2x, but now plus 7. I have 3 terms. What's a word for 3? That sounds mathematical. Trinomial. And once we get to 4, 5, 6, that's when textbooks will start calling them polynomial with 4 terms. Okay, an example, you can come up with any one that you want. 7x cubed minus 2x squared plus 3x minus 1. Okay, so we have all this different terminology. We have degrees. We know how to identify degrees based on the polynomial. We know how to count the number of terms in a polynomial. And then we can classify the polynomial based on either the degree or the number of terms. So if you are given a polynomial like 3x cubed minus 2x, or a polynomial like 5x squared plus 3x minus 7, or a polynomial like 4x minus 6. We can name these. Okay, so if we're naming this black polynomial based on the degree, we would call it a cubic. If we were naming it based on the number of terms, we would call it a binomial. If we were naming this red polynomial based on the degree, we would call it a quadratic. Ooh, spelling. It's the reason why I am a math teacher. Quadratic. And if we're naming it based on the number of terms, trinomial. And then finally, with the degree of 1, if we're naming this based on the degree, this would be a linear. And if we're naming this polynomial based on the number of terms, binomial. So hopefully this helps you understand what these different terms mean, where they come from, how to classify different polynomials. So in later videos, if we're saying something like this quadratic binomial, or these two binomials, or this constant term, you'll know what these words mean and be able to understand them so that you can focus on the other parts of the lesson in the later videos, whatever those are covering. The next episode in the quadratic series is going to be talking about multiplying polynomials. We're specifically going to be talking about the foiling method for multiplying polynomials. If this video helped you out, consider subscribing. Consider liking the video. And if you still have a question and you're confused, please go ahead and comment, and I'll be around and try to help out the best I can. Thanks, and we'll see you in the next one.